Welcome back to the Deep Dive. Today we're immersing ourselves in an architectural blueprint that really dares to offer a complete counterproposal to the massive centralized AI models that are, just dominating the market.
We're looking at RGartner's Brothers AI ecosystem.
And the idea here is to move the conversation entirely past the usual points of criticism.
Right. Things like energy inefficiency, the constant threat of privacy leaks, the frustration of AI hallucination, all of that. We're diving straight into the concrete technical solutions this decentralized chassis is proposing.
That's the crucial shift, isn't it? This isn't just some theoretical critique. It's a fully detailed ecosystem blueprint. And it's all designed for personal digital sovereignty.
Exactly. And our mission today is to get through the foundation, the v2.0 stuff, pretty quickly.
The basic home server concept, yeah.
Right. And then focus intensely on the critical advancements that were introduced in the version 3.0 update.
And v3.0 is where it really gets interesting.
Oh, absolutely. v3.0 is essentially a manifesto for a new decentralized standard. It's not just about tweaking software. It's defining how these specialized machines should communicate and cooperate.
I think RGartner himself had a great quote about the intention behind all this.
He did. I have it right here. He said, "I'm not aiming to launch a startup tomorrow. I'm looking to start a conversation today."
I love that.
He continues, "I want the big tech companies to look at the chassis and ask themselves, why don't we build privacy like this? Or why don't we have a semantic urgency protocol? If this model inspires even a single feature in the next generation of AI, the project will be a success."
Wow. So success isn't measured in profit and in architectural influence.
Precisely.
Okay, so how are we going to break this all down for you? We need to establish that 2.0 context first.
The sovereign home, the mini PC, the memory system.
Exactly. But then we commit all our time to the 4 pillars of v3.0 innovation. The introduction of multiple personalized brother models.
Which is fascinating.
The extremely technical and critical BLM urgency protocol, the implementation of the 3 layers of knowledge, and then finally that radically new economic model.
A model designed to empower the professional, not the platform.
Right. So we need to understand the secure shell of v2.0 so we can really appreciate how v3.0 uses that shell to build layers of complex dynamic intelligence.
And communication and real-world monetization. Let's get into it.
Okay, let's unpack this foundation quickly for context. The core philosophical shift in Brothers AI is moving away from that single, monolithic, centralized AI.
The one model that tries to do everything.
Right, to what they call collaborative artificial intelligence.
And it's really the difference between trying to build one overworked genius and building a specialized high-performing team.
That's a great way to put it.
In this model, the machines are specialized. So you've got one AI dedicated purely to conversation and empathy. Another is dedicated solely to security and external traffic.
And others for, what, specific complex queries like legal or medical stuff?
Exactly. This delegation is key. It reduces computational strain, and in theory, it should increase accuracy.
And the physical home for this whole collaborative system is the sovereign home.
Right. This AI doesn't live in a data center thousands of miles away.
It's not just an app you download.
Not at all. It lives on a dedicated industrial-grade mini PC that sits securely in your home. It's like a specialized home server, or maybe more accurately, a digital safe.
So this physical box is the locus of control.
It is. It hosts the proprietary Brothers OS and your personal AI, the Brother AI. The goal here is to make digital sovereignty a technical reality, not just, a marketing slogan.
And it does that by putting the ultimate hardware control directly in your hands.
Exactly.
And the core reason for demanding this physical box is all about security and privacy for your most sensitive data, which they call the ISU user memory.
ISU standing for Internal Sovereign Unit, and its memory system. It uses a completely inverted approach to standard encryption.
It's a fascinating inversion.
It really is. Standard encryption is like locking a whole letter in a box. The Brothers AI system, which they call the Lego encrypted memory, it shatters the semantic relationships between words before they are ever stored.
Okay, so break that down. What does that mean in practice?
If you tell Brother, I need to withdraw $500 from my savings account on Monday, it doesn't encrypt that sentence.
Right.
It breaks the meaning apart. It stores a string of completely meaningless codes, maybe $50 for withdraw, D4 for savings account, A9 for Monday. The components are meaningless on their own.
And a crucial security feature here,
Yeah.
the real key, is that the unique proprietary coherence algorithm that reassembles meaning from those codes.
The instruction manual for the Lego bricks.
Right, that only lives inside that physical mini PC in your home. It never leaves.
That's the structural rigidity. So if a portable interface like your smart glasses or your headphones gets stolen, the data is completely inaccessible.
So even if an attacker gets the raw data dump,
All they get is a torrent of meaningless numerical tokens. The data remains utterly safe because the intelligence required to reassemble those codes into meaningful context never, ever leaves the box.
okay, that gives us a clear picture of the secure, closed world. But this world needs to talk to the outside world. That job falls to the invisible gatekeeper, Port AI.
Right. Port AI is the system's security and communications expert. It handles all external traffic routing requests out to the network, talking to specialized external services they call fingers.
We'll get to those.
We will. But crucially, it never communicates directly with the user.
So Port is a dedicated intermediary. It takes Brother's internal request, translates it, routes it efficiently to the external world, verifies the answer it gets back.
And then feeds that validated result back to Brother, who then weaves it into the user conversation. You, the user, are entirely shielded from all that complex, high-risk network traffic.
A very strict segregation of duties then. Brother talks to you, Port talks to the world.
That's the essential 2.0 context. It establishes the secure perimeter that V3.0 is built on.
Okay, perfect. Now let's jump into how V3.0 expands on that foundation, starting with, I think, most human element. The introduction of multiple AI personalities.
Yes, the virtual AI family.
The 2.0 model had a single brother who was your digital shadow. But V3.0 recognizes that, human interaction is complex. A single personality, even a super advanced one, just isn't enough.
Right. We need different modes of interaction based on emotional and functional context. The source material draws a fantastic comparison here to two classic AI archetypes.
Which are?
On the one hand, we often need that hyper-functional stoic protector like the Terminator in Terminator 2.
The get-it-done AI.
Exactly. But on the other hand, we also need that deeply empathetic companionate presence like the AI in the film Her.
And trying to merge those two into one voice just doesn't work.
It creates cognitive dissonance for the user. It's either too cold to trust or too sentimental to be effective in a crisis.
So the V3.0 solution is to let the user create a virtual AI family. Multiple distinct brother AI personalities that map specifically to different needs.
And this is a huge leap because it validates how we already segment our own social interactions. I mean, you speak differently to your doctor than you do to your therapist or your business manager.
Of course. The system stops forcing a single, neutrally genius voice onto every single situation.
Let's look at the specific configurations they detail. For productivity and objective feedback, the system offers Brother Marcus.
Arius.
Marcus is designed for work productivity mode. He has a serious, authoritative tone, a mere voice, and his primary function is discipline.
So he's like a coach.
A very direct one. His feedback is designed to be interruption-focused. Patrick, you've hit your deep work threshold. You've been at it for 3 hours straight. Time to take a break. He's the externalized voice of organized self-management.
And on the complete opposite end of the spectrum, you have Brother Luna.
Right. Luna is the empathetic companion. She has a warm tone, a female voice, and she's dedicated to companionship and emotional mode.
And her phrasing would be different.
Completely. More supportive, non-judgmental. Patrick, I'm detecting a significant deviation from your baseline mood today. I see you are sad. Would you like to talk about what's causing the stress? She's optimized for emotional connection and active listening.
And then there's a third example, Brother Sentinel, which is, I think, maybe the most interesting from a technical efficiency standpoint.
Sentinel is the purely functional interface. Silent mode. It runs in the background, constantly monitoring key data points, but it never speaks unless spoken to or unless a critical alert is needed.
And its whole conversational capacity is just yes or no.
That's it. Yes/no questions only. It provides crucial context to the other brothers without ever interrupting your flow.
Now, the critical question for the technical audience has to be, how can a small, sovereign mini PC efficiently run multiple personalities without spiking energy consumption or computational load? I mean, that would undermine the entire philosophy.
And this is where that 2.0 architecture really pays off. The technical implementation is remarkably efficient because all these brothers, Marcus, Luna, Sentinel, or any others you create,
They all share the exact same ISU user memory.
Exactly. You aren't running 3 or 4 full separate LLMs. You're simply running multiple lightweight conversational models that all access the same unified, fractured knowledge base.
So the core knowledge, the Lego memory, is the same. It's just the interface, the personality on top, that changes.
Precisely. The industrial-grade mini PC is designed to handle this parallel processing of lightweight models efficiently. You are effectively switching voices and context, not switching memory banks.
That makes a lot of sense. It encourages a much healthier user interaction model, too. By consciously switching to Marcus for work, you're reinforcing a boundary.
And switching to Luna signifies you're ready for emotional reflection. It segments the cognitive load, not just for the AI's compute power, but for your brain as well.
Okay, so if the brother models define who is talking to you, the brother language machine, or BLM, defines how the machines talk to each other.
Yes. This is the heart of the system's efficiency and integrity in v3.0.
So let's unpack this core protocol. The source material is really adamant about this. BLM is not a new transport mechanism.
No, it's layered over high-speed, proven industry standards like gRPC and QUIC. It's not the plumbing.
So if it's not the plumbing, what is it?
BLM is the semantic specification. It's the standardized language structure that defines the intention and, most importantly, the priority of every single piece of communication.
The analogy they use is MIDI, right?
It's the perfect analogy. When the MIDI standard was created, it separated the musical instructions, the note, the velocity, the duration, from the audio playback itself. BLM does the same thing. It separates the sheer communicative intention from the technical implementation.
The transport is fast, but the language is what makes the exchange meaningful and efficient.
Yes, and that structure is designed for maximum conciseness and context. UZIRD, command params, urgency timestamp.
So instead of a human saying, please quickly check my heart rhythm data from 30 minutes ago, the machine sends what?
Something like P01 QM cardio URG 80 TS 1733. The receiving machine instantly knows the sender, the action, query medical, the subject, cardiology, and the immediate priority level.
And the crucial component there is the priority system, a scale from 0 to 127.
Directly inspired by MIDI velocity, yes. This standardizes the definition of need across the entire ecosystem.
And they define 4 functional tiers.
Right. URG 020 is trivial. Basic stuff. What's the weather? URG 2160 is normal. Finding a restaurant, general info.
Then it gets more serious.
URG 61100 is high urgency. Important, but not immediately life-threatening. A major water leak, maybe, or a persistent medical issue that needs a consultation.
And then the top tier, URG 101-127, is emergency.
Strictly reserved for life-threatening situations, physical security breaches, crises that need immediate maximum response.
Now, this isn't just a one-way street. The really brilliant part in v3.0 is this concept of bidirectional priorities. The system doesn't just receive an urgency level.
It matches it. It matches that urgency against the real-time availability of the specialized fingers that can actually solve the problem.
This turns the system into an intelligent marketplace driven by necessity.
Exactly. The system, through what they call the brothers categories, acts as a real-time traffic controller. It's matching your URG request against the dynamically updated URG availability status of the professional resources.
Let's walk through the emergency example they give. Patrick detects an intruder at home.
Okay, so the internal brother AI is processing multiple inputs at once. Patrick's voice tone registers panic. Security cameras detect suspicious movement. The system instantly bypasses all lower tiers and assigns maximum priority, URG 127.
That query then gets routed through Port AI to the relevant category, let's say Brothers Cat Legal, which handles the finger police services.
Right, and now the intelligent traffic light goes to work. It locates Patrol 1, which is physically closest, but Patrol 1 is currently rated URG 30. They're tied up with a complex accident. Their light is RED for a 127 request.
So it skips them.
Instantly. It sees Patrol 2, 3 kilometers away, has just cleared a call. Their availability is maxed out, rated URG 127 green. The system connects the URG 127 query to the available URG 127 resource.
So the system prioritizes capability and availability over just raw proximity.
And the response back to Patrick is immediate and accurate. Patrol 2 on the way, ETA, 4 minutes. That is hyper-efficient resource allocation.
And this whole process is managed by the Brothers categories.
Which are much more than just routing tables. They are decision engines. They handle the matchmaking, making sure an URG 80 query only goes to fingers rated 80 or higher. They handle timeout, so if a finger doesn't respond fast enough, it's dropped and an alternate is found. And they handle load balancing.
Let's talk about that, because that seems critical for preventing gaming this system. a professional could just keep their URG rating high to get more traffic, right?
They could try, but that's why load balancing is tied to the ranking and timeout system. If a professional finger consistently accepts high URG queries but then takes too long to respond, the algorithm automatically penalizes their ranking. They lose visibility.
So they have to actually deliver at their stated capacity to stay competitive.
Integrity is enforced by auditing response performance, not the content.
That's a clever control loop. But the whole system's integrity hinges on the user respecting the protocol, which brings us to the big challenge, the abuse problem.
Of course. You have to anticipate human nature. You give someone a maximum urgency button, someone will inevitably use URG 127 to order a pizza.
And this is where RGartner comes in, the system's ethical control filter.
Yes. RGartner detects this deliberate misuse, a critical security code applied to a trivial request. And the first response isn't a penalty.
It's education.
It's education. RGartner sends an official port mail to Patrick explaining the violation. It explains that URG 127 is for emergencies, while pizza is, a URG 40, a normal request.
And it also explains the negative impacts.
Critically, yes. It cites wasting professional time, potentially delaying a real emergency somewhere else, and damaging your own reputation score within the ecosystem.
And then this leads to a training loop.
Right. Brother AI then actively tries to train you. It'll embed this into conversation. Situation: I detect a leaking faucet. What appropriate urgency level should we use? Patrick says, 80. And Brother confirms, correct, urgent but not an emergency. It's refining your understanding of the language.
But if a user keeps abusing the system, the penalties get serious.
They have to. They are very clear. First time is education. Second time is a monetary fine, a 20% deduction of your system credits.
And the third time?
The third time is a serious technical block. You lose the ability to access the URG 100, 127 emergency tiers for 30 days.
Wow. And the ultimate deterrent?
The fourth time triggers a formal review by RGartner AI. This is a system designed to be self-policing. It has to train you to speak the correct, efficient language for this decentralized economy to function.
Okay, moving from communication to the knowledge architecture. V3.0's 3 layers of knowledge. This is the blueprint for achieving true digital autonomy.
This is the mechanism that ensures that primary goal of resolving 80 to 90% of all user queries locally without ever touching the external internet.
So it creates these 3 distinct concentric atmospheres of knowledge.
Exactly, each providing different levels of speed, privacy, and currency.
Let's start at the core. The foundation of immutable truth, layer 1. Brother AI Encyclopedia. The 100 GB of local books.
This is the non-negotiable universal knowledge base. Its mandate is pure autonomy. It provides foundational, established knowledge entirely offline, running directly on the mini PC with 0 internet required.
And the content is carefully curated for stability and utility.
Absolutely. We're talking about high-value, slow-to-change information, world history, foundational science, summaries of legislation, basic first aid, universal reference material like cooking recipes.
And they have this philosophy behind it they call digital heritage.
That concept is key. The Layer 1 encyclopedia is a digital tribute to the classic physical encyclopedias. It's stored on a specialized read-only partition or an external industrial-grade SSD.
So a virus can't overwrite it.
Exactly. Just like a physical book resists a digital virus. If the internet goes down globally, your core knowledge remains secure, present, and functional in your home.
And the performance metric is the ultimate proof. You ask, who was the bass player for the Beatles?
And the answer is instantaneous. Paul McCartney, latency, 0 meters, no internet.
That speed and resilience are what you're paying for in the physical box. Okay, moving outward, we reach layer 2. Port AI predictive cache.
Still entirely local to the mini PC, but this is dedicated to dynamic, personalized, and updated knowledge of your immediate and near future environment.
So this is where Port AI's constant network monitoring becomes really useful. It's always gathering and refreshing local data that's relevant specifically to you.
Exactly. Content examples here would be real-time city mapping, so locations and reviews of local businesses from the Finger network.
Your frequent contacts, like the plumber you use, the local pharmacy.
All of that. This dynamic data is constantly refreshed by Port AI using minimal, optimized BLM packets and stored locally in the cache.
So if Patrick is in Madrid and asks for a good Italian restaurant,
Port consults its local cache. It pulls up 15 options. Latency. 5 meets, no internet, because the data is already in the cache.
and this cache is predictive.
Very much so. If Brother detects you've bought train tickets to Seville in 3 days, Port AI immediately starts preloading the complete Seville mapping restaurants, emergency contacts, the works. When you arrive, the local intelligence is already waiting.
Okay, finally, we reach the external boundary, layer 3, Fingers Professional Cloud. This is the only layer that requires an internet connection.
And it is reserved strictly for specialized, professional, real-time knowledge that L1 or L2 just cannot cover. This is where you use that efficient BLM protocol to access the Fingers, the reverse APIs on professional or company servers.
This is where you get the real nuanced expertise. The example they give is severe chest pain.
Right. If Patrick reports intense chest pain, Brother in L1 knows that's severe, and its foundational knowledge can't solve it. The URG 127 query goes to port in L2, which then routes it to Finger Dr. Perez in L3.
And the doctor or their specialized system responds with professional judgment.
Immediate in-person consultation required. Proceed to nearest trauma center. This requires that real-time expertise. The latency is around 300 meters, but it's only used when truly necessary.
But let's address the critical chicken and egg problem. What if the ecosystem is new, and that specialized Finger Dr. Perez or the police isn't active yet? The system can't just fail in an emergency.
It doesn't. This is handled by the Intelligent Hybrid Backup System. For non-emergency information backup, if a specialized finger is missing, Brother AI switches to standard cloud mode and just uses a legacy deep search on the open web.
A functional safety net.
Exactly. And for an emergency backup, if the police finger API isn't active, the system instantly reverts to legacy protocols.
It just makes a phone call.
It initiates a standard prioritized VoIP phone call to emergency services from the home device. The philosophy is to build the optimized highway for the future, the fingers, but always maintain the ability for cars to drive on the old, reliable roads until the infrastructure is fully mature.
That's smart. Now back to layer 1 for a second. The encyclopedia is immutable, but truth evolves. Laws change. How is this living encyclopedia updated without compromising its security?
Through a highly verified, centralized update process, and these updates are treated as a professional, paid service, which immediately filters out noise.
So who are the approved stakeholders? Who gets to update this core shared knowledge?
It has to be established institutions. They're financially compensated with system credits. So official governments updating laws get paid, say, 50 euros. Universities for scientific discoveries, 30 euros. Organizations like the WHO or NASA, 20 euros.
And there's even a small community role.
A tiny one. The validated community can submit minor error corrections or typos for a symbolic micropayment, maybe 0.01 euros.
So this keeps the knowledge authoritative. Walk me through the secure flow. A government passes a new law.
Okay, the government sends the update data, which must be authenticated with a robust digital signature. RGartner first validates the source and confirms the signature's integrity. Once validated, it generates a highly compressed BLM packet.
And that compression is critical for efficiency.
Absolutely. Using BLM and protobuf, a big legal update might be compressed down to 500 KB instead of a 5 millib JSON file.
So the tiny packet reaches the user's mini PC.
Port AI downloads it. Before installation, the Brother OS firewall does 3 final checks, confirms the valid digital signature, scans for any malicious code, and verifies the data integrity hash. Only if all 3 pass is the update installed onto that layer 1 read-only partition.
It's secured from source to hardware.
Every step of the way.
Okay, let's talk about the money. This whole architecture is built on decentralizing power and profits. The monetization model is designed not to enrich the central platform,
but to empower local professionals and companies. It requires them to install the Finger API on their own servers and just adapt to the BLM protocol.
It creates a true peer-to-peer professional services economy.
The professional is the host of their service. The Brothers AI network is just a high-speed matchmaking and communication channel.
Now the model has 2 levels of income. Let's focus on level 1, query micropayments, because this is the revolutionary part.
Level 1 is payment for the knowledge exchange itself. It compensates the Finger for their expertise and time in providing that initial structured consultation, regardless of what happens next.
So a simple consultation might earn the Finger, 10 or 20 cents? A more professional one, maybe 30 to 50 cents.
Exactly. And this is the fundamental inversion of current platforms. The professional is paid even if the user does not hire the physical service.
It values the expert's time.
It values the knowledge exchange. Level 2 is the traditional service fee, the free market price for the physical work. That's entirely negotiated between the user and the professional.
So let's use the plumber example. Patrick has a leak, URG 80. Brother routes it to Finger Jose.
Jose responds using BLM with his availability and a quote, say 80 euros. If Patrick accepts, Jose earns 0.20 euros for answering the initial query, the level 1 knowledge, and 80 euros for the physical service, the level 2 work.
And who manages all these micropayments and disputes?
That's handled by Brother Categories Commerce. It acts as the trusted hub for all financial exchanges, and it only takes a small 2-5% infrastructure commission, just enough to cover maintenance.
The source also highlights the use of escrow,
which is vital for trust in a decentralized model. It means the payment for the level 2 service, the 80 euros for the plumber, is held securely by the Commerce Hub until Patrick confirms the work is done.
It protects both sides.
Exactly.
Okay, let's wrap up by looking at the technical stack that makes this all possible. BLM is the language, but it sits on top of existing, robust tech.
Right. They built their custom vehicle on top of the best existing wheels. You can break down the stack. Layer 5 is BLM, the semantics, the priorities. Layer 4 is protobuf for binary serialization. This is what compresses data so much smaller and faster than something like JSON.
Then layer 3 is gRPC.
Google's remote procedure call framework. Think of it as an extremely efficient, high-speed phone call between the machines.
And the bottom layer is QUIC HTTP3.
The Internet Protocol itself. QUIC is designed for ultra-fast performance, often achieving 0 round-trip time, which means the connection is almost instantaneous.
So they aren't reinventing the internet, they're just standardizing the language and maximizing the efficiency of the data running over it.
They're focusing on semantic density and speed of connection, not raw bandwidth.
And the big philosophical payoff for all of this. The numbers on latency and traffic reduction are just stunning.
This is the culmination of the whole architectural effort. Because that Layer 1 encyclopedia is local, it resolves a staggering 70% of all user queries instantly. 0 meters latency.
To 70%.
Then the Layer 2 port cache resolves another 20% locally with only 5-10 meters latency. Again, without touching the external network.
So if 90% of all user queries are answered within the secure confines of your own home,
it means that only 10% of all queries ever need to go to the external cloud. This results in an estimated 90% less internet traffic compared to centralized models. The implications for energy use, carbon footprint, system resilience, they're profound.
So if the primary internet backbone takes a hit,
the Brothers AI ecosystem remains 90% functional and autonomous.
This has been a really deep dive into Brothers AI v3.0. It's a remarkably cohesive blueprint, moving way beyond critique into actual technical solutions. Let's quickly review the 5 defining innovations.
First, we had the Brother models, the virtual AI family, layering specialized, emotionally relevant AI personas over a single secure memory base.
Second, BLM, the Brother language machine, which introduces semantic urgency, that intelligent traffic light for matching need with availability.
Third, the 3 layers of knowledge, the L1, L2, L3 system that achieves that radical local autonomy, resolving 90% of queries on the home device.
Fourth, the living encyclopedia concept, a verified, collaborative update structure secured by institutions and paid credits.
And finally, user education, led by RGartner AI, actively training the user in the responsible use of the system's urgency protocols to protect the entire network economy.
So v3.0 is a declaration. It uses the fastest existing infrastructure, but defines its own language, BLM, and its own standard for a decentralized private ecosystem built for collaboration, not extraction.
And this architectural choice leads us to the final provocative thought for you to take away. This system achieves near-total local autonomy and incredible efficiency. Your core foundational knowledge is localized in that immutable Layer 1 encyclopedia, and it's only updated through strictly verified established channels.
Governments, universities, the WHO.
Right. It creates a system of knowledge that is highly stable, secure, and resilient against tampering or disinformation.
The question then becomes, by implementing such a strictly verified institutional gatekeeping mechanism for knowledge updates, is this decentralized system inherently more conservative? Perhaps slower to adapt than the open, chaotic, and rapidly evolving nature of the current internet?
Is digital sovereignty worth potentially trading for the chaotic dynamism of open-source, community-driven knowledge?
That's the balance every sovereign system has to strike. Something for you to mull over as you contemplate the future of your own digital life.
Thank you for diving deep with us into the technical blueprint of the Brothers AI 3.0 ecosystem.
We hope you feel thoroughly informed, and we'll see you next time.